the trick is this. So I've got object 1 coming in, object 2 as at rest, and I'm going to put them on a boat. And this boat is traveling towards the left at a speed v. So a person on the boat, when they watch this collision happen, they see the simple case that we just solved. The simple case is this thing here, where object 2 is at rest, object 1 comes in with some speed that we'll call v1 initial, right? This is according to this person here. And this person is going to see a simple elastic collision, and the answer that this person is going to arrive at, or that's going to make sense to this person, is this answer. So this person will see this answer as what happens to v1 after the collision. But I'm going to consider that this person is actually part of an experiment on a boat, and this boat travels leftward at speed v. And so I would like to take the point of view that somebody on the ground, what do they see? What this person sees is, right, if you, oh, actually, let's see. Yes, I'm so sorry. Let's point this way. I'm sorry. In my head, this is easier for me to think about. So this person's on the ground. This boat travels sideways at v. So when this person looks at this object, they give it an initial velocity that's also to the right. So I'm going to say that this is a prime, and it's equal to v1 initial as measured by this person on the boat, plus the motion of the boat itself. What's interesting is v2 initial, according to this person is known as prime. It's the other coordinate system to watch nature happen in. v2 initial prime, so this is number 2. Number 2 is at rest with respect to the boat, so it's moving at v, right? So this is, you know what these are, is velocity transforms for relative motion. It's likely in your course in physics that you may have studied relative motion, and you would have equations like this on how to make a judgment call for what the velocities in a different frame of reference are, if you know what they are in a frame of reference. Yeah, so here is, I'm going to use relative motion as my trick. So what I know is this person is going to see, so this person will see v1 final, which is equal to the thing we got over here. So it's m1 minus m2 over m1 plus m2, multiplying v1 initial. So what I'm going to do is I'm going to transform and ask, well, what will it have to be in the prime frame? So v1 final prime is equal to v1 final plus v, just like v1 initial prime is v1 initial plus v. So that's the case here. So let's go in and figure out v1 final prime. So v1 final is this stuff here, So it's m1 minus m2 over m1 plus m2. So v1 final is this business here times v1 initial. And then the idea is you add on v. So v1 final prime is this, but this person, they want v1 final prime in terms of v1 initial prime and v2 initial prime. Just like this person would like to see v1 final in terms of v1 initial, not primed, and v2 initial, which happens to be 0 for this person. So this person wants to see it in terms of v prime, so let's give it in terms of v prime. So these masses here, they don't change. This person and that person will always agree on what the masses are. That's actually quite an interesting physics story all by itself. But so the masses are the same, independent of the frame of reference or the relative motion, but v1 initial, this is how you understand v1 initial. v1 initial is equal to v1 initial prime, and you subtract the v over, right? So I can get that equation there, and so v1 initial, I'll just replace it with stuff in terms of primes, like this, and it turns out that this v right here is actually v2 initial prime. Ooh, I've made a mistake somewhere, I think. So v1 final prime. No, I didn't make a mistake yet. Haha. Okay, so I forgot this plus v. I just replaced v1 initial, but I forgot to include the plus v. Haha, so that's pretty cool. So I've got v1 initial prime minus v. That turns into v1 initial prime minus v2 initial prime plus v2 initial prime. So this, if we just continue with the algebra, we get v1 final prime equals, so I've got m1 minus m2 over m1 plus m2. So that is hitting the v1 initial prime, right? It's also hitting, I'll put a minus sign here. So minus m1 minus m2 over m1 plus m2. On v2 initial prime. That's this times this, but I've got another v2 initial prime. I'm going to do a little bit of an algebra trick and just add on, because there's a plus. It'll be m1 plus m2 over m1 plus m2, which is a factor of 1. There's a 1 in front of v2 initial prime. So that looks like that. And then if I go and I do some more cleaning up, this looks like m1 minus m2 over m1 plus m2, v1 initial prime. And then this thing, if you look at it, see the minus sign? It can hit the m2 with the minus sign and the plus sign on the m1. It can flip their order, and this becomes m2 minus m1, v2 initial prime. So let's do it this way. So it goes plus. So here's the plus term. It's m1 plus m2 minus. So it goes minus m1, and then minus times minus is plus, plus m2, all divided by m1 plus m2, like that, on v2 initial prime, and this equals. So you can see there's a lot of stuff that can happen in here. the M1s cancel. So there's actually not that many things that happen, but the M2 doubles up. So we get M1 minus M2 over M1 plus M2, V1 initial prime, and then in here this goes plus 2 M2 over M1 plus M2, V2 initial prime. And then M1 plus M2 is common in the two terms. So it looks like this finally. M1 minus M2 V1 initial prime plus 2M2 V2 initial prime, all divided by M1 plus M2. Which is here. So we used a trick. We had an algebra problem that was really, really hard in a particular reference frame. But if we moved to a reference frame where the problem was easier algebraically and we solved it there, we could later on move back into the original reference frame and sort of update our answer into a new reference frame. And it turns out the algebra is a little easier that way. Or at least I think the concept is easier that way, or something like that. I'm not sure. But yeah, so that's that.